Good morning, students. Today I'm going to present classical encryption techniques, substitution and transposition cipher, which are the basics for modern cryptography. Cryptography is the science of securing information by converting plain text into ciphertext. The two major classical approaches are substitution cipher and transposition cipher. Substitution cipher, in which one text is replaced by the other text, and then transposition cipher deals with the rearrangement of the characters. That means we are changing the position of the characters. These techniques played an important role in cryptography and network security. So in this classical encryption techniques, how we are providing security for our information from unauthorized users. Okay. So next one. There are two types of encryption techniques are available, symmetric and asymmetric. Symmetric encryption uses two or more keys, one is public key and then private keys. Asymmetric keys uses shared secret key. So symmetric encryption, this is the main conventional or private key or single key encryption methods. Here sender and receiver share a common secret key. Encryption and decryption performed using the same key. Most classical cipher belongs to the same category. Example, Caesar cipher, Placeper cipher, Hill cipher. So these are all the some basic terminologies. Plaintext, ciphertext, cipher key. Plaintext is the original message. Ciphertext is the encoded message. Cipher is which type of algorithm we are using for converting the plaintext into ciphertext. Key is which information used in the particular algorithm. In cipher, converting plain text to ciphertext. Decrypt, recovering ciphertext from decipher means decrypt. Recovering the plain text from ciphertext. Cryptography is the study of encryption method. So these are the things we have analyzed in the some basic terminologies. And then symmetric encryption model. So here sender and receiver share the common secret key. Encryption and decryption are performed using the same key. Most classical cipher belongs to this category. Example, Caesar cipher, Placeper cipher, and Hill cipher. So in this, sender encrypts a plaintext message using a secret key. The encrypted plaintext has been transmitted through a communication channel. The receiver uses the same key to decrypt the message. The output is the plaintext output. So next one is plaintext requirements of a secure encryption. There are two requirements. That is, the first one is the encryption algorithm that should be strong enough. And then key should be a secret key that is only known to the sender and receiver, no third-party usage. Mathematically, then requirements of expressions, the encryption decryption algorithm can be represented as encryption algorithm represented by the key Y, that is EK of X, and then for the decryption algorithm, we can get back the original plaintext message by decrypting the ciphertext message Y with the help of the same key. Here E represents the encryption algorithm, D represents decryption algorithm, X and Y represents plaintext and ciphertext. So next one. Cryptography. Cryptography we have already analyzed. The cryptographic system is classified based on the types of operation, substitution or transposition, number of keys, single keys, two keys, processing method, block cipher, everything. So crypt analysis, the process of finding the secret key or original message without knowing the key. So there are two approaches, cryptanalytic attack, brute force attack. So next one, cryptanalytic attacks. So cryptanalytic attacks are and brute force attacks. These are the some cryptanalytic attacks, ciphertext only, non-plain text, chosen plain text, chosen ciphertext, chosen text. So next one is how the brute force attack can happen in this model symmetric crypto system. Here the message X is transferred using encryption algorithm, that is Y is a ciphertext. The ciphertext message can be captured by a cryptanalyst to decrypt the message, or they can able to find the key with the use of the ciphertext. Okay, this is the secure. By using secure channel, the key secret has been shared through sender and receiver. Cryptanalysts can identify the secret key by the trial and error methods. Okay. So next one. there are the particular algorithm should be unconditionally secure and computationally secure. These are the things they have been discussed here. So next one. Classical substitution cipher. Here in each substitution cipher, each letter is replaced by another letter or symbol. Position remains unchanged. Only symbols are substituted. Types of substitution cipher. Major substitution ciphers are CC cipher, monoalphabetic, Playfer cipher, Hill cipher, and polyalphabetic and one-time pad. So first one, Caesar cipher. Caesar cipher is developed by Julius Caesar. Working principle of the Caesar cipher is each letter is shifted by 3 positions. For example, consider the letter A. That should be shifted 3 times, A, B, C, and D. The A letter should be replaced by the letter D. So this is the formula for encryption. C equal to P plus K mod 26. For the same time, decryption performs in order to get the plain text by using the decryption of the same ciphertext C minus K mod 26. So these are the example for Caesar cipher, how the A will be converted to D by using the encryption formula, and then the same thing, decryption, how we can get the original plain text message by using the ciphertext message. Activity problems. So next one, drift analysis of Caesar cipher. How there are only 26 possible ciphers are available. There is drift analysis can easily find out the possible keys. So these are the main limitations of Caesar cipher. There are only 25 keys are used to try. So drift analysis can easily find out the keys, so that way they can easily convert get back the plain text. So next one is monoalphabetic cipher. Monoalphabetic cipher in which attackers can try all possible correct plain text is easily here identified. So here also the same letter frequencies can be easily identified. So next one, Playfer cipher. Playfer cipher deals with the Charles Wheatstone. The main feature of this Playfer cipher is encrypts 2 letters at a time, uses 5 plus 5 matrix, provides strong security than single letter substitution. Example here, keyword monarchy. So Playfer encryption rules here is more secure. Rules are, so if the 2 letters are fall in the same row means replaced by the right letter. Also in the same column means replace by below letter. If it is falls in different row, different column means replace using opposite columns. The main advantages of this Playfer key matrix is more secure than Caesar and then monoalphabetic cipher. More secure than Caesar and monoalphabetic ciphers. And then the main security of Playfer cipher is Playfer encrypts instead of single letters. Therefore, frequency analysis also becomes harder. Requires more ciphertext for successful attacks. So next one, polyalphabetic cipher. Polyalphabetic cipher in which one or more by using this one or more letters we can substitute the letters. Okay. So this is the polyalphabetic cipher, in which Virginia cipher comes under best. This is the main simplest polyalphabetic substitution cipher. Here key is multiple letters long. So here, consider for example, keyword here is deceptive. By using the deceptive and the plain text keyword, if the first letter of this key and then first letter of the plain text, how intersect in which row and which column this which box intersect, that will be considered as the ciphertext. Suppose for example, the plain text message is V are discovered. V means W-E. Consider the letter W and deceptive word D. Where the D and W words are intersect, the ciphertext here word is CZ. Okay. So that way, single digit compared to Caesar cipher, this is more advantageous one. Frequency distribution here, that is easy to because it is difficult to find out the frequency of the particular letters. So next one, one-time pad. One-time pad uses random key. Here key length is equal to message length. Key is used only once. Advantages: statically unbreakable. Limitations are difficulty key generation, difficulty key distribution. So next one, Hill cipher. Hill cipher, it is developed by Hill. It uses matrix multiplication, mathematical approach to encryption, works on group of letters. Main advantages here is stronger than earlier substitution techniques. By using the matrix multiplication formula, we can get back the ciphertext. So the next one is transposition cipher. So up to now, we have seen substitution cipher like Caesar cipher, Wafer cipher, Hill cipher, Virginia cipher, monoalphabetic and polyalphabetic ciphers. Next come to the second technique, classical encryption technique, transposition ciphers, in which we are changing the instead of changing the letter, here we are changing the position of the characters. We are performing permutation operation here without altering the characters. There are two types of transposition ciphers are there, railfence and conventional transposition. So railfence technique in which we have to write the plain text message in the sequence of time and read it in a row ways. For example, meet me after the Toko party, we have to write it as diagonal wise. First, we have to write in the diagonal wise and then we have to see in the row wise. We can get the ciphertext. Same thing, columnar transposition. Columnar transposition in which we have to write the letters of message in rows over a specific number of columns. That means we have key is the number of columns where we have to spend out the original plain text. Then reorder the columns according to the sum before reading the rows. For example, consider this example, meet me in London tomorrow. So our key value is 342157. So that means we have to write the plain text as it is, meet me in London tomorrow, like the remaining letters substitute by XYZ. That is considered pillar characters, and we have to read the characters in ciphertext by the number of columns specified in the key. Suppose the number first column in which how many letters present in that column, that should be comes first, T N O Z, and after that 2 E O N O. Then next comes then 3 M and T W. The next ones. Activity problem. So these product ciphers things and all will used for features. Okay. So next one. So mainly our conclusion is cryptography ensures confidentiality and security of information. Substitution ciphers replace characters while transmission cipher replaces them. Classical techniques such as Caesar cipher, Wafer cipher, Virginia Hill, and transmission cipher, it will form the foundation for modern cryptographic algorithms. So although classical ciphers are not sufficient secure today, understanding them helps to appreciate how modern encryption systems have developed. Thank you.